Hey everyone, in this tutorial, we'll create a third-person controller in Unity that looks like this. So we won't be using any assets to build it. We'll build it completely from scratch because it's a good way to learn the fundamentals of 3D game programming, and it'll give you the knowledge to customize the controller for your own games. So while building the controller, you'll learn lots of important concepts like how to use Unity's character controller component, how to implement camera-related movement, how to use humanoid retargeting for reusing animations on multiple characters, how to use physics for ground detection, etc. So there are lots of things that you learn while building this. And by the way, this is actually the first module of our Udemy course, Unity third-person Parkour system. In the course, we'll build on top of this controller and create a more advanced controller that can use Parkour to traverse dynamic environments like this. So I'll put a link in the description if you want to check out the whole course. So with that, let's start the video. So first, we'll start by creating the Unity project. So I have my Unity Hub opened over here. So I'll click on the new button to create a new project. So let me just name this something like Parkour System Course. All right. And I'll change the template to Universal Render Pipeline, just in case you want to use the shader graph or the VFX graph in the future. All right. So let me go ahead and hit the create button, and it should create the project for us. So this will take some time. So I'll pause the video and get back to you once it's over. All right, so the project has been created. So the URP project comes with some example assets. So we don't need them. We're going to build everything from scratch. So let me go ahead and delete the example assets. And I'll also delete the folder containing the example assets. Okay. And then we can also delete the tutorial info and the README file. We don't need them. So next, let's create a new scene. So inside the scenes folder, we already have a scene over here, but I want to create a new one. So I'll go to create and select scene to create a new scene. So let me just name this something like test scene. And I'll double click to open it. So here I'll add a new plane game object. So under 3D object, I'll select plane. So this will act as the ground of our scene. All right. So let me just reset its position so that it's at the center. And I also want to make this plane a little bigger. So I'll change the X and Z scale to something like 5. All right. We have a much bigger plane. So next, I want to change the material of the plane. If we use a plane material like this, then it will be hard to understand if our character is moving or not. So let me create a new material for this. So under the materials folder, I'll right click and create a new material. So I'll call this material checkers. All right. And under the surface input, we can change the texture of the material. So if you click on the base map, you can select the texture that you want to use. So I'll just use this default checkers texture that comes with Unity. All right. So now we can drag and drop this material to the plane to apply it. So it's applied now, but the checkers are a bit big. So I'll increase the tiling to 10 to make the checkers small. So that looks good. So now we have set up the scene to work with. So next, we can start building our third-person character controller. So we'll start by building the camera of our third-person controller. So first, I'll add a capsule to the scene, which we can use as the player for now. All right, let me name this player. And I'll double click on it to focus. And let me just place it above the ground. All right. So now we want our camera to look at this player and rotate around it, right? So let's go ahead and write a script to achieve that. All right, so in the scripts folder, we already have a script called simple camera controller, but we are not going to use that. We're going to build our camera controller from scratch. All right, so let me go ahead and delete it. And then I'll create a new script called camera controller. All right, so let me get rid of all the default code in the script. And in the script, what we want to do is, first we want to place the camera behind the player at a distance like this. All right, so this is the player and this is the camera. So we want to place it behind the player at a distance. So in the camera controller script, first we need a reference to the object that we want to follow, right? So here I'll create a serialized field variable of type transform, and I'll call this follow target. All right. And next, we want to place the camera at a distance behind our follow target, right? So in the update function, we can set the position of the camera to follow target dot position minus the distance by which we want the camera to be behind, right? So I'll subtract follow target position by a new vector, and this vector will be 0 in both x and y, and in the z we should provide the distance. So for now, let's say we want the camera to be 5 units behind the player, so I'll just put 5 for the z. All right, so let's go to Unity and see the result of this. So first we need to attach the camera controller script to our main camera. All right, so let me just drag and drop it over here. And then we need to assign the follow target object. So let me just assign the player as the follow target. So now let's go ahead and run the game. All right, so you can see that the camera is placed behind the player at a distance. So we can actually minimize the game view and take a look at it from the scene view. So you can see that the camera is behind the player and its Z position is -5. Since the player's Z position is 0, so it's placed 5 units behind the player, right? Just like we specified from the script. So that's working, but it's not good to hard code numbers like this in the code. We should make this a variable and expose it in the inspector so that the designers can easily tweak these values without touching the code, right? So let me create a new variable for that. All right, I'll make it a serialized field so that it's exposed in the inspector. And this will be a float variable, and I'll just call it distance and set its value to 5 by default. Okay, so now in here, instead of hard coding 5, I'll use my distance variable. Okay, so now if you go to Unity, we can change the distance value from the inspector, right? So let me just put it back to 5. All right, so now we are placing the camera behind the player at a distance. So next, we should rotate the camera around the player when we move the mouse, right? So we should rotate the camera both horizontally and vertically. But first, let's handle the horizontal rotation. So how can we rotate the camera around the player like this? So for that, all you have to do is just rotate this vector, right? So this is that vector. And if we rotate this vector by multiplying it with the rotation, then it will be rotated like this based on the angle. So let's go ahead and try this out in Unity. So to rotate a vector, we just have to multiply it with a rotation. So let's say we want to rotate this vector by 45 degrees. So for that, first we need to create a rotation of 45 degree. So I can do that by using quaternion dot Euler. All right. And in which axis should be rotated? So the rotation here is horizontal, right? And if you want to rotate something horizontally, then we should rotate it in the y-axis, right? So in the quaternion dot Euler, I'll put 0 for the x, 45 for the y, and 0 for the z. So this will create a rotation of 45 degree in the y-axis. So if you're not familiar with quaternions and rotations, I've already covered that in the introduction section of this course. So be sure to watch that first. All right. So this will create a rotation of 45 degree. And then to rotate this vector, all you have to do is just multiply this quaternion to this vector. All right. And this will rotate this vector by 45 degrees. So let's go to Unity and see the result of this. All right, I'm going to play the game. So now you can see that the camera is still behind the player, but now it's at a 45 degree rotation, right? So this will be more clear if you look at it from the scene view. All right, so if I just go to the top view in the scene, you can see that the camera is placed behind the player at a 45 degree angle. All right, so that's working as expected. So next, we want to rotate the camera around the player like this when we move the mouse horizontally, right? So that is pretty simple to achieve. What we can do is we can create a float variable over here called rotation y, and then in the update function we can add the mouse x input into the rotation y variable. All right, so I'll say rotation y plus or equal to input dot get axis mouse x. All right, so we'll be adding the joystick in the future, but during the implementation, let's keep this simple and use the mouse. So now in the quaternion dot Euler, we can use rotation y instead of just hard coding 45. All right, so let's go to Unity and see the results. So you can see that as I move the mouse, the camera is rotating around the player, but right now it's not looking at the player, but it's still rotating around the player. All right, you can get a better view of it from the scene window. Okay, so yeah, you can see that the camera is rotating around the player in a circle. Okay, so that's working fine. So next, we should make the camera look at the target when we rotate around it, right? So that's pretty easy to achieve. All we have to do is set this rotation as the rotation of the camera. All right, so first let me store this rotation into another variable so that we can reuse it. So I'll call this variable target rotation. All right, and here I'll multiply the vector with the target rotation, and then we can also set this as the rotation of the camera. So I'll set the transform dot rotation to the target rotation. Okay, so now the camera should also look at the player. So let's go ahead and test it. All right, so now you can see that as we rotate around the player, the camera is constantly looking at the player. So that's working. So now we are done with the horizontal rotation of the camera. So next, we should also rotate the camera vertically like this, right? So this is going to be just like the horizontal rotation. The only difference will be for vertical rotation, we should rotate it around the x-axis. So here I'll create another variable called rotation x, and then we should rotate the camera vertically when we move the mouse up and down, right? So to the rotation x, I'll add the mouse y input. All right, let me just copy this line and change it to mouse y. So this might be a bit confusing to some of you because we are adding mouse y to rotation x and mouse x to rotation y, right? But the reason for this is because for horizontal rotation, we should rotate around the y-axis, and for vertical, we should rotate around the x-axis, right? So if that's confusing to you, take a minute or two to think about it, and you'll get a hang of it. All right, so let's continue with the vertical rotation. So here, I need to add the rotation x to the x of the Euler, and now we should also be able to rotate the camera vertically. All right, let's go ahead and test it. So now if I move my mouse up and down, you can see that we can rotate the camera vertically, okay? But in the case of vertical rotation, we want to clamp it to some limit, right? We should not be able to rotate all the way around the character like this, right? So we should set a limit to how much we can rotate vertically. All right. So we can easily limit that by clamping the rotation x value. So to clamp a variable, we can use mathf.clamp. And what this function will do is it'll take a min and max limit. And if the value goes beyond the limit, then it'll just clamp the value to the limit. So in this case, rotation x is the value that we want to clamp. And then we should define the min and max limit. So I'll create variables for the min and max limit, and I'll make them serialized field so that we can tweak it from the inspector. Okay, so I'll call the first variable min vertical angle, and let me set it to something like -45 by default. All right, and then I'll duplicate this line. And by the way, you can duplicate a line in Visual Studio by using the Control D shortcut. All right, so I'll duplicate the min vertical angle variable and create another one called max vertical angle. So I'll set this one to plus 45 degrees. All right. So now we can clamp the rotation X between the min vertical angle and the max vertical angle. Okay. So let's go to Unity and test this. And by the way, I'll just make sure that the min and max angles are correct in the inspector. And I'll go ahead and play the game. Okay. So now I can't move the camera above this limit. I'm clamped over here. And if I go down, okay, this minimum angle is a bit too much, but I'm clamped over here. I can't go beyond this point, right? So the clamping is working properly. So we're done with the vertical rotation, but there is actually a problem. Right now, the camera is actually looking at the bottom of the player, right? It's not pretty obvious right now, but when you bring in an actual character model, the camera will be looking at the feet of the model, and that'll look really weird. So the camera should actually look at the chest or the head part of the player. So we can easily achieve that by adding an offset to our target position. So here I'll create a new vector2 variable and I'll call this framing offset. Okay. And then instead of using the follow target dot position directly, I'll add the framing offset
to the follow target position. All right. And let me store this in a variable called focus position. So this is the position to which the camera should focus. Okay, we can't simply add these two like this because follow target dot position is a vector 3 and the framing offset is a vector 2, right? So we can't directly add them. So here I'll have to create a new vector 3 and then I'll have to pass framing offset dot x and framing offset dot y. Okay, so that solved the error. And now we have focus point. So here, instead of using the follow target dot position, I'll use the focus position. So let's go to Unity and test this. All right, so right now it's still looking at the bottom because we didn't set the offset in the inspector. So let's try changing the framing offset from here. So here you can see as I increase the Y offset, our focus position gets higher and higher, right? So let me just set it to a value like 1 for now. We'll adjust this further when we bring in an actual character. All right, so that looks much better. So next we also need to limit the minimum vertical angle. This is a bit too much. We should not be able to go below the ground, right? So let me try setting it to something like -20. And by the way, here you can see that the framing offset has been reset to 0. This is because we changed its value when we were in the play mode, and whatever changes that we make in the play mode will always be reset when we exit the play mode. All right, so let me set it back to 1. And now let's go ahead and test if the vertical angle is fine. So yeah, that's okay. So now we are done with the vertical and horizontal movement of the camera. All right. So there is one more thing I want to add before I stop the video. So I want to be able to control the speed at which the camera moves. So that is pretty easy to achieve. When we are updating the rotation X and rotation Y variables from here, we can multiply the mouse input with the speed value. All right. So here I'll create a new float variable called rotation speed. And let me just set it to 2 by default. Okay. And then I'll just multiply the rotation speed with the mouse input. All right. So let me also do it in this line. Okay. So now we should also be able to control the rotation speed of the camera from the inspector. All right. So it's 2 right now, but if you want, you can increase it to a higher value. So next, I want to hide the mouse when we are playing the game. So right now, you can see the mouse when the game is being played. So I want to hide that. So to hide the mouse, we have a property called cursor.visible. So I'll set that property from the start function. So let me create the start function over here. And in the start function, I'll set the cursor.visible property to false. So this will make the cursor invisible. And then we can also lock the cursor by setting cursor.lock state to cursor lock mode dot locked. All right. So now we won't see the cursor when we play the game. All right. So you can see that the cursor is not visible anymore. And now if you want to stop the play mode, you should first press the escape key. So this will make the mouse visible again, and then you can go ahead and stop the play mode. Alright, so just keep that in mind. So now we have a decent third-person camera, but there's one more thing I want to add. So some people prefer the camera direction to be inverted, right? So let's add a setting for that in our camera controller script. So here I'll add two new Boolean variables. So the first one will be called invert x, and the second one will be called invert y. So if the invert x is true, then we should invert the x rotation. So we can easily do that by multiplying the mouse input with -1, right? So what I'll do is I'll create two more variables for the invert value. So first one will be called invert x val, and the second one will be invert y val. Okay, and we'll set its value from the update function. So if the invert x is true, then the value will be -1, and otherwise the value will be 1. All right, so let me store this into invert x val variable, and then I'll also do the same for the invert y val. All right, so now we can multiply the invert x val with the mouse x input, and we can also multiply invert y val with the mouse y input. Okay, so this should allow us to invert the camera movement. So from the inspector, I'll turn on invert x and invert y. All right, so now when we test, the camera movement should be inverted. All right, so now we have a basic third-person camera setup. So next, we'll import a model for our player instead of using a capsule, and we'll look at how to make a character move like this. So the character movement will be related to the camera, just like we see in all third-person games. All right, so first I'll replace this capsule with an actual character. When implementing character movement, we won't be able to see the rotation properly if we are using a capsule. Alright, so let me switch this with an actual character. So I'll be downloading the character from a website called mixamo.com. So this site has lots of good characters and high quality animations, and they're completely free. So I'll open up mixamo.com, and you'll have to create an Adobe account to use this. Alright, so I'll go to the characters section and download a character. So the character I want to use is Erika. Alright, so this is the character I want to use. So I'll click on it and then click use this character. So once you do that, you'll be able to see the character in this window. And by the way, you don't have to use this same character. There are lots of different characters to choose from. Alright, I'll just go with this character. So let me click on the download button. And for the format, we have to select FBX for Unity. And then we want the pose in the pose itself. So just make sure these two options are correct. And then you can click on the download button and the character will be downloaded as an FBX file. Alright, so I've saved it to my desktop. So now let's go ahead and import the character into Unity. So under assets, I'll create a new folder called models. So this is where we'll put all the 3D models. So next, I'll drag the FBX file that I downloaded into the models folder. Okay, so the model is imported. So I'll drag the model to the scene so that we can have a better look. Alright, let me just get rid of the capsule now. So yeah, you can see the character model, but it doesn't have any textures on it. So to fix that, select the model, and in the Materials tab, click on the Extract Textures button. Alright, so we need to specify a folder in which the textures will be extracted. So here I'll create a new folder for that. Let me call it Textures. Alright, and I'll select this folder. Okay, so now we're getting this warning saying that normal map textures should be marked as normal map. So here we just have to click on the Fix Now button and it'll automatically fix it for us. Alright, so now we have the textures. Awesome. So next let's implement the script to move this character. So inside the scripts folder, I'll create a new script called player controller. Alright, so let me open it up in Visual Studio, and I'll also get rid of the default code. So in this script, we should move the player based on the input of the user, right? So first I'll get the input from the update function. So let me create the update function over here, and then I'll get both horizontal and vertical input. Alright, let me store the horizontal input in a variable called h, and then I'll also get the vertical input, and I'll store it in a variable called v. Alright, so we have the input. So next let me create a vector based on these two inputs. So I'll call this vector move input. Alright, so this will be a vector 3, and the x value of the vector will be the horizontal input, the y value will be 0, and the z value will be the vertical input. Alright, so this is a direction in which we should move the player. And here we have to do one more thing. We have to normalize this vector. So I'll use a normalized property to normalize this vector. So what this will do is, this will set the length of the vector to 1. If we don't do this, then the diagonal movement will be faster than the movement in a single direction. So that can be solved very easily by normalizing the vector. Okay, so now we have the movement input. So next we should move the character based on this input. So to move the character, I'll update the transform.position, and to the position we can add move input so that the character will move in the direction of the input, and then we should be able to control the speed of the movement, right? So for that I'll create a variable called move speed, and let me just set it to 5 by default, and here we should multiply the move speed with the movement input. Alright, so now the character will move in the speed, and finally we should also multiply this whole thing with time.delta time so that the movement is frame rate independent. Okay, so now the character should move based on our input. So let's go to Unity and test it. Alright, so first we should assign the player controller script to our player. So I won't attach it to the model directly. Instead, I'll create an empty game object here called player. Alright, let me reset its position. And then I'll make the model a child of the player game object. Okay, I'm doing it like this because in the future we'll have to add more things to this player game object. Alright, so now we can go ahead and attach the player controller script to the player, and then in the camera controller script the follow target reference will be missing because we deleted the capsule. So now let's go ahead and assign our player. Alright, so now let's go ahead and run the game. So the camera is moving around the player just like before. And now when we press the WASD keys or the arrow keys, the character should move. Alright, so the character is moving. So if I press the up arrow key, it's moving forward. If I press the down arrow key, it's moving backwards. And then it's also moving left and right when I press those keys. Alright, so the movement is working as we expected, but this is not how the character should move in a third person setup, right? Right now, when we press the forward input, the character is moving in its forward direction, but it should actually move in the camera's forward direction, right? In a third person controller, the movement of the player should be relative to the camera. So to achieve that, all we have to do is multiply our move input with the rotation of the camera, right? This will make the movement relative to the camera. So first we need to get a reference to the camera from the script. So let me actually create a variable for the camera controller over here. All right. And then I'll cache a reference to it from the awake function. So since the camera and player are attached to different objects, we can't simply use the get component function. Instead, we'll have to get the reference to the camera's game object first. So we can get the reference to the camera's game object by calling camera.main property. And then on that, we can call get component and get the camera controller. Okay, so let me cache this to the camera controller variable. And now we can multiply the move input with the rotation of the camera. Alright, so I'll get the rotation from camera controller.transform.rotation, and then I'll multiply it with the move input. Okay, so I'll store this in a variable called move direction. I'll just say dir for short. And then here I'll use the movement direction variable instead of the movement input. So this should rotate the movement input in the camera's direction. But there's actually a problem with this. Our character should only be able to move in the XZ plane, right? It should only be able to move in the horizontal plane. So when we multiply the move input with the camera's rotation, we should only take the camera's horizontal rotation. We should not take the vertical rotation. So if we use the vertical rotation, then the player will also be able to move up and down. So we don't want that unless you're making a player that can fly. So let me go to Unity and show you what happens when we use the complete rotation. All right. So here the movement is related to the camera, but the player can also move up and down. So if the camera is facing up like this, then the player will be able to fly. All right, so we don't want that. So here we should only take the horizontal rotation of the camera. So we can get the horizontal rotation from rotation Y, right? So what I'll do is in the camera controller script, I'll create a new property called planar rotation. So this will be the rotation in the XZ plane or the horizontal plane. All right. And in this property, we should return a quaternion. So I'll create a quaternion by using quaternion.Euler. And here we should only consider the Y rotation. We should not consider the X rotation like we do over here. So I'll pass 0 for the X rotation, and then I'll pass rotation Y variable for the Y, and then I'll pass 0 for the Z. So this will give us the planar rotation of the camera. And now from the player controller, we can simply multiply the move input with the planar rotation. All right. And by the way, if you're not familiar with properties in C#, I'll explain it real quick. So properties are a pretty cool feature in C#. So usually in most programming languages, if you want to return something like this from a class, you would create a public function, right? So usually you would create a public function like get planar rotation, and then from that function you would return this value, right? So this is how you would usually return something from a class. But in C Sharp, we have a cool feature called properties. So properties are just like a function. The only difference is they won't have this parenthesis that a function has, right? So you don't have this feature in most of the programming languages. So I just want to give you a quick explanation in case you don't know what properties were. And by the way, if you want to use a function over here like this, it's totally fine. I just like using properties since they are shorter. Alright, so let me get rid of the function. So now the movement input is only multiplied with the planar rotation. So the character shouldn't be able to move up and down. Alright, so let's go to Unity and test it. Alright, so the character is not able to move up and down, but it is moving related to the camera. So now when I press the forward key, it's not moving in its forward direction. Instead, it's moving in the forward direction of the camera, right? So that's working fine. So next, when moving the character should rotate and face the direction in which it is moving, right? So we just have to set the rotation of the character to make it face in the right direction. So from here, I'll also set the rotation of the character. So we want the character to face in this move direction, right? But move direction is a vector, and for the rotation, we have to pass a quaternion. So we can actually get the rotation from a direction vector by using quaternion dot look rotation function, and we have to pass the directional vector in the parameter of this function. Okay, so this will make the character face in the direction in which it's moving, but we should really update the direction when the character is moving, right? So how can we check if the character is moving? So for that, I'll create a new variable called move amount over here. So this variable will be a sum of horizontal and vertical input. And if the move amount is greater than 0, then that means the character is moving and we can update the rotation. Alright, but we can't simply add the horizontal and vertical input like this. We should remove the sign of the horizontal and vertical input, right? Here, we don't care about the direction of the input, we only care about the amount. So if the horizontal input is -1, we should remove the sign and make it 1. So to remove the sign from a value, we can use the mathf dot abs function. So here abs stands for absolute, since this function returns the absolute value by removing the sign. Alright, and let me also do it for the vertical input. And now if the move amount is greater than 0, then that means the player is moving. So we can move the code to set the rotation inside this if, and we can actually move this line also, because there is no point in trying to move the character if the input is 0, right? So I'll actually move these two lines inside this if condition. Alright, so now the character should face in the direction in which it's moving. Okay, so let's go to Unity and test it. Alright, so you can see that the character is facing the move direction. Okay, but the problem is the character is rotating instantly, right? That looks really weird. We don't want the rotation to be instant. we want it to rotate smoothly, right? So let's look at how we can achieve that. So to make the rotation smooth, we should not set the rotation directly like this. Instead, I'll store this rotation in a variable called target rotation. All right. So here, instead of setting the rotation directly, I'll store it to the target rotation variable. And then outside this if condition, we can slowly change the current rotation of the player to the target rotation, right? So to slowly change one rotation to another, we have a function called quaternion dot rotate towards. All right. So in the first parameter, we have to pass the from rotation. So here the from rotation will be the current rotation of the player, and then to rotation will be the target rotation. And finally, in the third parameter, we should pass the amount by which we should change the rotation. So using the third parameter, you can control how slow or fast the rotation change should happen. So I'll actually create a variable for that called rotation speed. All right. And I'll set its value to something high like 500 by default. The reason is because the function expects the rotation amount as an angle in degrees. So here 500 is the angle of rotation. All right. So now we can pass it as the third parameter. And then we should also multiply it with time.delta time to make it frame rate independent. And finally, we should set the value returned by this function to our transform dot rotation. All right. So this will smoothly rotate the player instead of rotating it instantly. And by the way, let me split this into two lines because I don't like lines that are really long. Okay. So now let's go ahead and test if the rotation is working. So I'll just select the player and make sure that the rotation speed is 500. All right. So now let's go ahead and test it. Okay. So now it's rotating smoothly. You can actually play with the value of rotation speed and find a speed that you like. I think this is fine. So we successfully made our character move based on the input. So next, we'll set up the animations that we need. We'll look at a concept called humanoid retargeting in Unity, which will allow us to reuse the same animation on multiple models. So first, let's download the animations that we need. So I'll be downloading all the animations from Mixamo, the same place from which we downloaded our character. So here you also have animations. So if you click on this animations tab, you can browse all the animations available in Mixamo. All right. And by the way, before you start selecting and downloading the animations, make sure to select the character that you downloaded in the previous video. So in my case, the character is Erika. All right. So I'll select the character and click on use this character. All right. So make sure to do this before you start downloading the animations. This is important because when you download the animations, Mixamo will automatically make it compatible with the character that you selected. All right. So now let's look at the animations that we need. So first, we need an idle animation. So here I'm going to search for idle. So you have lots of variations. I'll just go with a simple idle like this one. All right. And by the way, you have few settings over here. You can play with it if you want to modify the animations. So here for this animation, the hand of the character is really close to the body. So if you want to have more space between the hand and the body, then we can increase the character arm space.
So let me increase it to something like 68. All right, that looks better. So I'll go ahead and download this animation. So while downloading, you have few settings over here. So for the format, make sure to select FBX for Unity, just like we did for the character. And then you can download it with the skin or without the skin. So if you select with skin, then it'll also download the character that we selected. So in our case, we have already downloaded the character, so we don't want to download that again. So I'll set it to without skin. All right. And then for the frames per second, leave it at 30 and leave the keyframe reduction at none. All right. So make sure these settings are right, and then click on the download button to download the animation as an FBX file. So I'll just name this idle and save it. Okay. So next we need a walking animation. So let me search for walking. And again, we have lots of variations. Let me try this one. All right, this one looks okay. So for the walking animation, make sure to check the in place checkbox. All right, so once we check that, the character will only play the animation. She won't actually move while playing the walking animation. All right, so in our game, for character movement, we don't want animation to control the motion of our character. We want our code to control it, right? We wrote the code for it in the previous video. So be sure to check the in place checkbox to remove any motion in the character. Alright, so now I'll go ahead and download it. I'll use the same settings as before. So let me just name this one walk. And finally, we need an animation for running. So let me just search for run. Okay, I'll just go with this one. Again, we have to check the in place checkbox to make sure that we don't have any motion with the animation. Alright, so now I'll go ahead and download this. So I'll call this one run. Alright, so now we have the animations. So let's go ahead and import them to Unity. So in Unity, in the assets folder, I'll create a new folder called animations. And then I'll import the three animations that we downloaded right now. Okay, so now you can check if an animation is working by selecting the animation and then selecting the animation tab. And at the bottom, you should be able to preview the animation. But right now it says we don't have a model and we have to drag a model to this preview area. So let's go ahead and drag our model into the preview area of the animation. All right. So now if we press the play button, you can see that the animation is working on our model. All right. But the reason why this animation worked with this model by default is because Mixamo made this animation compatible with our character since that was the character that we selected in Mixamo, right? So the problem is if we bring in another model to our project, the animations might not work on them. So let me show you by importing another model. All right. So this is another character model that I downloaded from Mixamo. So let me drag him to the inspector and I'll check if the animations are working on this model. Okay. So if I drag this model onto the preview of the animation, you can see that when I press the play button, the animation is not playing on the character. So these animations won't work on other characters. So that's a problem. We don't want to download separate animations for separate models. We want to be able to reuse the same animations. Luckily, Unity has an easy solution for this. So before we look at the solution, let's look at why the animation is not working on different models in the first place. So if you expand the game object of our character model, you can see that it has bones under it. All right. So it has bones for all the parts in its body. And now if you look at the second character, it also has bones. But the problem is the names of these bones are different, right? So usually the models that are created by different artists will have different bone names. But the way animation works is by modifying the position and rotation of these bones. So if you expand the walk animation, you can see the animation clip over here. And if you double click on it, it'll open the animation clip in the animation window. So here you can see what this animation is doing. This animation clip is modifying the position and rotation of the bones of the character, and that's how it's achieving the animation, right? And here you can see that this animation uses the bone names of this character, right? The bone names of the wipeout character is different, and that's why the animation is not working on the wipeout character. So if you rename all the bones of the wipeout character and make it as same as this character, then the animation will also work on the wipeout character. But that solution is really tedious, right? We have lots of bones for a character, and renaming each and every one of it is really hard. So the good thing is Unity provides us with a solution in which we can solve this with just few clicks. So the solution is humanoid retargeting. So basically what we'll do is we'll map the bones of all the characters to a standard set of bones that Unity can understand. All right. So we'll do that for all the characters and all the animations. And once that's done, the animations will work with all our characters. All right. So let me show you how to do humanoid retargeting. So for this, first we have to select the character, and then you have to go to the rig tab, and in here you have to change the animation type from generic to humanoid. All right. So this works by creating an avatar. Avatar is a thing that maps the bones of a character to the standard set of bones. So in the avatar definition, we have to select create from this model, and then all you have to do is hit apply. All right. So you can see the tick mark over here. So that means Unity was successfully able to map all the bones. In case Unity was not able to map it automatically, then you'll have to click on the configure button, and this will show you all the mappings that were done by Unity. All right. You can see that over here. So if some bones are missing from the mapping, then you'll have to manually drag and drop it over here. All right. So I'll click on the done button to go out of the avatar. And you can also see the avatar over here. So this is my character, and inside it, we have the avatar now. All right. So now we should also change all our animations to humanoid. So let's go ahead and do that. So first, let me just select the walk animation, and in the rig tab, I'll change this to humanoid. And then for the avatar definition, we have to select copy from avatar in the case of animations. And then we have to select the avatar that we created earlier. All right, so let me go ahead and assign that avatar. And now we just have to hit apply. All right, so we have to do this for all the animations. We have to make them humanoid. So let me select the other two animations and also make them a humanoid animation. All right. So now the animation should work on our Erika character. All right. And then it'll also work on the whiteboard character if we turn it into a humanoid. So let's go ahead and do that. So in the rig tab, I'll change it to humanoid. And since this is a model, I'll select create from this model for the avatar definition. And then I'll hit apply. All right. So it was successfully able to create the avatar and map the bones. So now the animations should also work on the whiteboard character. So let's go to the animation tab and preview the animation on the whiteboard character. Okay, so the animation is working fine. So that's really easy to set up. All you have to do is just change your characters and animations to humanoid when you import them to your project. So next, if we preview our animations, you'll see that we have a slight problem. Let me just make this big so that you can get a better view. All right. So here at the bottom of the player's feet, you can see a circle and the circle is moving, right? So if the circle is moving, that means the animation has some kind of motion in it. But in our case, we don't want to use the motion of the animation. We want the character movement to be controlled from the code completely. So we have to get rid of this motion. And by the way, if we drag our other character, the main character that we are going to use, so here also you can see the circle is moving. So this motion is called root motion. It's really useful in some cases. For example, for an attack animation where the character is jumping and swinging the sword, we could move the character from the animation itself instead of moving it from the code. But in the case of idle walk and run animations, we don't want to use root motion. We want the motion to be controlled from the code itself. All right. So the problem is when we turn our character into a humanoid character, it'll automatically set up the root motion. So that's what's causing this motion in the animation. All right. So we can easily fix this by using these three options. So here for the root transform rotation, root transform position Y, and root transform position exit, we should change all of them to original. All right. All of them should be original. And then we should also select bake into pose for all of them. All right. So now you can see that the circle is not moving anymore. It's stationary. So these options are really useful. We'll explore these options more in the future when we implement attack animations. But for now, just keep in mind that if we don't want to use root motion, then check bake into pose for all three of these, and then also change their based upon to original. All right. So I'll go ahead and hit apply. So now the circle is stationary. So now let's go ahead and do this for the other animations also. Unfortunately, we can't do this for multiple animations at once by multi-selecting them. So we'll have to do it one by one. So first let me do it for the run animation. All right. So I'll check bake into pose and change the based upon to original for all three root transforms. All right. And then I'll hit apply. And by the way, we also want these animations to loop. So let me also select loop time and loop pose to loop these animations while we are here. All right. And now let me hit apply. So now let me do the same for the idle animation. All right. And let me also check loop time and loop pose so that the animation will loop. All right. And finally, let me also turn the loop time and loop pose for the walk animation.
So now we are done with the setup of our animations. So next we can use these to animate our character when moving. So your character movement will look like this once you add animations. So let's look at how to do this. So to play the animations on our character, we have to create an animator controller. So let's go ahead and create that. So in the assets folder, I'll create a new folder called game. All right. So this is where I like to put all my prefabs and scriptable objects and animator controllers, basically all the things that a designer would want to use. So inside this folder, I'll create another folder called animator, and I'll create my animator controller over here. So in create, you can see animator controller. So I'll name this character controller. Okay. So now we can double click on it to open the animator controller. So animator controller controls what animation should be played on our game object. So we can drag all our animations in here and then define what animation should be played based on the parameters. So let me drag one of our animations in here. So I'll just drag the run animation. So let me rename this to run. So the first animation that you drag into the animator controller will be the default animation that will be played. So if I also drag the other animations, you can see that their color is different. Only the run animation is in orange color, right? So that's because this is the default animation. So now if we attach our animator controller to our character, then our character should play the run animation by default. So to attach an animator controller to a game object, we have a component called animator, all right? And in this component, we can specify which animator controller that we want to use. So I'll assign the animator controller that we created. And then we also need to assign the avatar of the character. So the avatar of this character is called Erika Archer avatar. So let me assign that. So now when we run the game, our player should play the running animation. All right. So you can see that it's working fine. So now let's also try attaching our animator controller to the second character just to make sure that the animation is also working properly on the second character. So on the whiteboard character, it already has an animator component attached to it. So Unity does this automatically when you turn a character into a humanoid character. And also over here, you can see that the avatar has automatically been assigned. Okay, so we just have to assign the animator controller, and the whiteboard character should also play the running animation. All right, so it's also playing the animation. So our animations are working fine on all the characters. So next, we don't want our character to simply play the running animation. We want to play different animations based on the speed in which the character is moving, right? So if the character is not moving, then we want to play the idle animation. And then if the character is moving slowly, then we want to play the walk animation. And then if the character is moving fast, then we can play the run animation. All right. So the animator controller, there are different ways to control what animation should be played. But in the case of movement animations, I want the animations to blend smoothly. So for example, instead of just switching from the walk animation to the run animation, I want to blend between them based on the speed. So to achieve that, I'm going to use a blend tree. So let me go ahead and delete these three animations. All right. And now I'll create a blend tree to blend between our animations. All right. So I'll name this blend tree locomotion. And then we can double click on the blend tree to open it. So here in the blend tree, we can add multiple animations, and the blend tree will blend between these animations based on the value of this parameter. All right. So in our case, we want to add three animations. So here I'll add three motion fields. Okay. So to the first one, I'll assign the idle animation. And by the way, we can't directly drag and drop the XPX file of the animation here. We can only assign the animation clip to it. All right, so we have to assign this animation clip. So to the first field, we have to assign the idle animation, and then to the second field, we have to assign the walk animation. All right, and finally, to the third field, we'll assign the run animation. Okay, so now in the preview window, if you play the animation, then the character will be in the idle animation. But now if you change the blend, then it will slowly start walking, and at point 5 it'll play the walking animation in the actual speed of that animation, right? So that's because here we have thresholds. So the threshold of idle is 0, walking is 0.5, and running is 1. All right. So when it's at 0, it'll be in the idle animation. When it's at zero point 0.5, it'll be playing the walking animation, and when it's 1, it'll be playing the running animation. All right. But the cool thing here is when the blend is between 0.5 and 1, it'll play a fast walking animation like this. So this is a blend between our walking and running animation. So this is why the blend tree is really useful. And also if I try setting the blend somewhere between 0 and 0.5, then it'll also blend between the idle and the walk animation. All right, you can see the character is doing a really slow walk, which is not really useful for us, but I just want to show you how the animations blend. The blending between the walk and the run animation, that is really useful. And by the way, you can also change the threshold of different animations. So right now it's not editable because the automate threshold checkbox is turned on. So if you turn it off, then you can edit the threshold values. So I'll just set the threshold value of the walking animation to something lower, like 0.2. The reason is because I want my character to start playing the walking animation as soon as it starts moving. So this is just a personal preference. You can play with this value and set it to one that you like based on how you want your third person controller. All right. So now we just have to set this blend parameter from the code, and the character should automatically play the correct animation. All right. But first, let me actually rename this blend parameter to something meaningful. So I'll call this move amount. So that makes sense, right? If the move amount is 0, then the character should be playing the idle animation. Then as we increase it, the character should start walking and running, right? So now let's go ahead and set this parameter based on the character's movement. So let me open the player controller script. Okay. So to set a parameter to the animator, first we need to get a reference to it. So I'll cache a reference to the animator from the awake function. I'll just use the get component function to get the reference of the animator. So now we should set the move amount parameter in the animator. So we are already calculating a value called move amount over here. So we can set the same value to the animator. So to set a value to the animator, we can call animator dot set. So when you type set, you can see that we have lots of options. So in this case, the move amount parameter is actually a float value.
right? So here we have different types of parameter. Move amount is actually float. You can see that its value is floating point. So to set the move amount from code, we can use a set float function. So in the first parameter, we should provide the name of the parameter that we want to set. So in this case, the name of the parameter is move amount. And then in the second parameter, we should pass the value that we want to set. So in our case, we are already calculating the value over here. So let me just pass that as the second parameter. Okay. And by the way, one thing I want to address is the move amount parameter should be between 0 and 1, right? But here, the value that we are calculating, it can be greater than 1. For example, if both horizontal and vertical input is 1, then its value will be 2, right? So we have to make sure to clamp this value between 0 and 1 to make sure that the animations are selected correctly. All right. So to clamp a value between 0 and 1, we have this function called clamp 0, 1. All right. We just have to put the value in this function like this. Okay. So now our character should play the animation correctly based on our movement. So let's go to Unity and test that. And by the way, let me get rid of the wipeout character. I just brought it in just to show you that the animations will work on multiple models. All right, so let's go ahead and test. So now when we move, you can see that our character is playing the animation correctly. All right, our third person controller is looking so much better when we added the animations. But if you look at how the animation stops, it's stopping really fast, right? It doesn't look very realistic. So the reason for that is because when we stop pressing the input, the move amount becomes 0 immediately. And when the move amount is 0, the character will start playing the idle animation immediately. So we can easily make this smoother by adding a damping when setting the move amount. So if you look at the third parameter of this function, you can see that we have a parameter called damp time. So if we add this parameter, then the animator will smoothly change the parameter to this value instead of setting it instantly. All right. So for the damp time, I'll pass a small value like zero point 0.2. And then when we pass the damp time, then we should also pass the delta time in the fourth parameter. So I'll pass time dot delta time in the fourth parameter. Okay. So this should smooth out the animations for us. So let's go to Unity and test. All right. So now you can see that the animation is not stopping instantly. It's slowly coming to a stop, right? So yeah, now we have a pretty decent third person controller. A small problem that we have here is the camera is going below the ground. So let's fix that by reducing the minimum vertical angle of the camera. Okay, let me try setting it to -10. All right, so now the camera won't go beyond this point. Okay, so yeah, our third person controller is looking pretty good. So there is one thing I missed to do while setting up the animations. So if you look at the idle animation, you can see that it is 8 seconds long and has 250 frames. So that's a bit long, and we don't want the idle animation to be that long. If you look at other animations like run and walk, you can see that they are much shorter. So having such a long animation can cause problems for us in the future when we transition to other animations. So we can make this shorter by reducing the end frame. We can just drag the slider to reduce the end frame. So I'll just make the end frame 30. All right. So now the animation is only 1 second long. So let's apply the change and let's just test to make sure that everything is working fine. All right. So things are working just like before. So next we look at how to set up collision and gravity for our character. So right now we don't have any collisions in our game. So let me add a cube to our scene so that we can test collisions. Okay, let me just make this cube a little bigger. All right, so now if we try walking through this cube, you can see that we don't have any collisions. So we need to handle that. So to handle collisions, we have two options. We can either use a rigid body or we can use a character controller. So for this project, I'm going to use a character controller. So let's look at the documentation of the character controller to understand what it does. So in the docs, you can see that the character controller allows movement constrained by collisions and it is not affected by any external forces. So this is an important point. If we are using a rigid body, it will be affected by external forces. So we don't want that for the player in our game. That can cause problems in the future. So we are going to go with a character controller instead of rigid body. All right. So let's go back to Unity and let's add a character controller to our player game object. So let me search for character controller. All right. So now in the scene view, you can see that there is a capsule collider. So the character controller comes with a collider and we can adjust the size of the collider by changing these values. So I'll change the height to something like 1.7 since that's the height of our character. So next we need to add an offset in the Y so that the collider fits the height of the character. So usually I like to set the Y a little above the half of the height. So the half of the height is 0.85. So I'll increase it a little and make it 0.9. All right. So this will make sure to keep the player's feet grounded. So next, we don't want the radius of the collider to be this big. So I'll set it to something small like zero point 0.2. Okay. And one more thing I like to do is I like to add a little Z offset somewhere around 0.08. So the reason for this is because our player will always face the direction in which it is moving. So collisions will mostly happen in the front side of the player. So I like to offset the collider towards the front side. All right. So we have set up the character controller. So next, when moving the player from the player controller script, we should not move it directly by updating the player's position. Instead, we should use a move function of the character controller. So that will make sure to constrain the movement by collisions. So we should use character controller.move function instead of this. So first, let's get a reference to the character controller. All right, I'll cache a reference to it from the awake function. Okay, so now to move the character, I'll use character controller dot move function. And for the motion vector, we can pass the same value as before. So let me just cut that and paste it over here. All right, and I can get rid of this line. So this will move the character just like before, but it'll also constrain the movement by collisions. So now let's go to Unity and test if the collisions are working. Okay, so now you can see that we can run to the cube. All right, so the collisions are working fine. So next, we should handle gravity and make the player fall when the player is in the air. So right now, if we place the player in the air and if we run the game, you can see that the player is not affected by the gravity and she can basically walk in the air. All right. So the character controller is not affected by any forces like the gravity. So we have to manually apply the gravity to our player from the player controller script. So to apply the gravity and make the player fall, first we should check if the player is in the ground or is in the air, right? We should only make the player fall if the player is in the air. So the character controller has a field to check if the player is standing on the ground or not. So the name of the field is grounded. So this will return true if the character is standing on the ground. But the thing is, I find this field of the character controller to be really buggy. Sometimes it can return wrong values. So I don't like using this. I like to manually check if the player is in the ground or not by using physics. So if you look at the implementation of the third person controller in Unity's starter assets, you'll see that even in this project, they are not using the is grounded property of the character controller. Instead, they are checking it manually by using physics. So let's also check that manually by using physics. So let me get rid of this line. All right. And below the update function, I'll create a new function called ground check. So from this function, I'll use the physics dot check sphere function to create a small sphere at the player's feet and check if there are any colliders overlapping in that sphere. Okay, so here you can see the description of this function. It will return true if there are any colliders overlapping in the sphere that we defined. Okay, so to create the sphere, we have to pass few things. We have to pass the position, the radius, and a layer mask. The layer mask is optional, but it's really important to use a layer mask when you're doing any physics operations. It'll make the operation a lot more efficient. If we provide a layer mask, then this function will only check for colliders in that layer. Okay, so I'll define serialized field variables for these three values so that we can control them from the inspector. All right, so first let me define a variable for the radius of the sphere. So I'll call this ground check radius. Okay, I'll set it to something like 0.2 by default. So next, for the position, we don't need a separate variable for the position. We'll be using the position of the player itself, but it would be nice to add an offset to the position. So I'll create a vector for the position offset. All right, let me call this ground check offset. So next, we also need to define a variable for the layer mask that we need to check. So I'll create a layer mask over here and I'll just call it ground layer. Okay, so now in the check sphere function for the position, we can pass transform dot position, but we also need to add the offset, right? So what we can do is we can transform the offset point based on the player's current position. So we have a function for that called transform point. So what this will do is this will transform the position from the local space to the world space, and it will transform it relative to the
transform that we are using here. Okay, so in this case, it'll transform it related to the player. So I'll call transform point, and for the point, I'll pass the ground check offset. Okay, so we have passed the position. So next, let's pass the radius. All right, and finally, we'll also pass the ground layer. Okay, so this will check if the player is standing on the ground or not. So let's actually create a variable to store the value of this function. So here I'll create a Boolean variable called is grounded. Okay, and I'll store the value returned by this function into the is grounded variable. All right, so now all we have to do is call the ground check function from here, and after that we'll know if the player is grounded or not from the is grounded variable. Okay, so let's actually use a debug.log so that we can test if the player is grounded or not. Okay, so next I'd like to visually see the spear in the scene. So this will allow us to set the offset and radius properly. And also if there are any issues with the ground check, it will allow us to understand what's happening. So we can achieve that by drawing a gizmo. So gizmos are the shape that you see in the scene. So for example, if you select the player, you can see the collider. So that's actually a gizmo. So we can draw a gizmo like that for the ground check spear. So to draw a gizmo, we can do that from two functions. The first one is on draw gizmos, and the second one is on draw gizmos selected. So on draw gizmos selected will only draw the gizmos if this game object is currently selected. So let's use that. So we can draw a gizmo by calling gizmos dot draw spear function. All right. So for the center, we can pass the player's position offset by the ground check offset. And for the radius, we can pass the ground check radius. Okay, so this will draw the gizmo. So we can also specify the color of the gizmo by setting the color before the draw function. So I'll set gizmos dot color. So I want the color to be something like a green. So in the RGB value of the color, I'll pass 0 for red, 1 for green, and 0 for blue. Okay, and I'll also pass 0.5 for the alpha because I want the spear to be a little bit transparent. All right, so now it should draw the ground check spear when we select the player in the scene. Okay, so you can see that it's drawing the ground check spear. So let's adjust these values. 0.2 is okay for the ground check radius. And for the ground check offset, I like to put the Y value at half of the radius. So I'll make it 0.1. All right. And I also like to give a little bit of offset in the Z so that the spear covers the feet. So around 0.07 should be fine. All right. So now the spear covers the feet of the player. So next we need to assign the ground layer. So what I'll do is I'll add a new layer called obstacles. So all the obstacles like the ground and this cube over here, all those will be in the obstacles layer. All right. So let's go assign the plane to the obstacles layer. And I'll also assign this cube. Okay. So now for the ground layer, we can just pass the obstacles layer. All right, so that's all we have to do. So let's go ahead and check if the ground check is working. All right, so right now, since the player is in the air, you can see that this grounded value is false. But if I go to the scene view and bring the player down to the ground, you can see that it becomes true. So our ground check is working properly. So now we know if the player is grounded or not. So next, if the player is not grounded, we should apply the gravity and make the player fall, right? So what we have to do is, to the move function of the character controller, we should also pass the vertical movement of the player, all right? So if the player is grounded, there won't be any vertical movement, and otherwise, we should apply a vertical movement to make the player fall down, okay? So the first thing I'll do is, I'll move this line out of this if condition. The reason is because the vertical movement should happen even if we are not pressing any input for the movement, right? Even if you're not pressing any keys, the player should fall down. So I'll move it outside the if condition. And then what I'll do is I'll put the movement vector in another variable called velocity. So let me define velocity over here. All right. And then we can use the velocity variable over here. So now we can also set the y component of the velocity if the player is falling, right? So if the player is not grounded, then we can apply a velocity over here to make the player fall down. And by the way, guys, if you don't know what velocity is just the speed of something at a certain direction. All right. So if you say a car is moving at 40 kilometers per hour, that's the speed. But if you say it's moving at 40 kilometers per hour in this specific direction, then that is the velocity. So it's just the speed with the direction. All right. So we have to set the y component of the velocity to make the player fall. So if you know how gravity works, you'll know that when something falls, it will not fall at a constant speed, right? Instead, its speed will keep increasing throughout the fall. So to be more accurate, every second the speed of the object will increase by the gravity. So we can't set a constant value here for the y velocity. We need to keep increasing it. So what I'll do is I'll create a new variable to keep track of the y speed. So let me create a float variable called y speed. All right. And then if the player is falling, then we should keep increasing the y speed by the gravity, right? So if the player is grounded, we don't want to do anything now. We want to increase it if the player is falling, right? So we want to increase it from the else part of this condition, okay? So if the player is falling, then we should add gravity to the y speed. So we can get the gravity in our game by using the physics dot gravity property. And we only want the y component of the gravity. So I'll just get the y. So this value is actually set from the project settings. So if you go to edit and select the project settings, in physics, you can see that we have gravity. So this is where the gravity of the game world is set. All right. So here, if the player is falling, we want to increase the y speed by the gravity, but we should also multiply this with time dot delta time. So this is because the y speed should increase by the amount of gravity every 1 second, right? But the update function is not called every 1 second. It's called multiple times in a second, right? So we have to make sure to multiply the gravity by the delta time, which is nothing but the value that has passed since the last frame. So now we are increasing the y speed if the player is not grounded. So let's set the y speed to the y component of our velocity. All right. And then if the player reaches the ground and his grounded value becomes true, then we should reset the y speed back to 0, right? But what I'll do is, instead of resetting it back to 0, I'll reset it to a small value like minus 0.5. So the small value will make sure to stick the character controller to the ground. All right. So this should make the player fall down if the player is not in the ground. So let me just get rid of the debug log, and let's go ahead and test if the player is falling. All right. So you can see that the player fell down. So the gravity was applied correctly. So let me also try placing the player out of this box just to test how it falls from such objects. All right. So first we'll fall to the box and we can move from here. But if we move past the ledge of the box, then the player will fall towards the ground. Okay. So if that's not working for you, there are a few things that you have to check. So the first thing to check is the value of the ground check radius and the radius of the character controller should be almost same. So if you make the character controller radius a higher value, then you'll have a bug where the ground detection will not detect any ground. But since the character controller is bigger, it won't allow the player to fall down. All right, so that's one thing to keep in mind. The radius and the Z offset of the ground check sphere and the character controller should be similar. They don't have to be exact same, but they should be in the same range. All right. So next, I just want to organize the player controller inspector a little. So I want some segregation between the speed variables and the ground check variables. So we can easily do that by adding a header above the ground check variables. So let me add the header attribute and I'll just call this ground check settings. Okay. So now there should be some segregation between the variables in the inspector. Okay. So yeah, we have handled collisions and gravity in this video. All right. But right now, the player can still move and play the walk animation when she's falling. We'll be fixing those in the future. But right now, this is a good start. So next, let's set the skin width property of the character controller. So this is a really important property. So if you go to the documentation of the character controller and if you switch to the manual, so the manual will have more detailed explanation when compared to the scripting API. So here we have a detailed explanation of all the properties. So if you look at the skin width allows other colliders to penetrate the character controller a little. So this is used to reduce jitter and it also prevents the character from getting stuck. So Unity recommends setting this to 10% of our radius. So in our case, the radius is 0.2. So the 10% of 0.2 will be 0.02. All right. So I'll set the skin width to 0.02. So next, we should change the Y of the center based on the value of the skin width. So earlier I told you that the Y should be a little above the half of the height for the character's feet to be on the ground. So if you want to be more accurate, we can set the center to half of the height plus the skin width. All right. So half of the height is 0.85 and the skin width is 0.02. So if we add that, we'll get 0.087. So this will place the feet of the player on the ground perfectly. So let's go ahead and test to make sure that it's working fine. All right. So you can see that the feet is planted on the ground perfectly. Okay. So next we'll set up controller input so that we can control the player with the joystick. So if you connect the joystick and test the game, you can see that we are able to move the player using the left analog stick, but we are not able to control the camera rotation using the right analog stick. All right. So if you look at the player controller script, here we are using the horizontal and vertical input to move the player. So Unity automatically sets up the horizontal and vertical input for the joystick. So that's the reason why we are able to move the player with the joystick. So you can actually see the input setup in the project settings. All right, so if you go to project settings and select input manager, here you can see all the inputs that Unity defines by default. So here we have horizontal and vertical, and over here we have another horizontal and vertical input, right? So they are defined 2 times. So the first one is defined for the keyboard. So here it uses the left and right keys. And the second one is defined for the joystick. All right. Here it uses the x-axis of the joystick. So like this, we should set up all our inputs for the joystick. So we want to be able to control the camera using the right analog stick, right? So if you look at the camera controller script, right now we are just using the mouse X and mouse Y input for controlling the camera. So instead of this, we should set up a new input over here and we should set it up for both mouse and joystick. So here I'll create two new inputs called camera X and camera Y. So I can just duplicate this mouse Y input to create a new input. So we can right click and select duplicate array element. All right. And I'll name this as camera X. So we want this to be controlled by the mouse. We'll create another one for the joystick. So here the type should be mouse movement and I'll change the axis to x-axis because this is camera X. All right. So now we can just duplicate the camera X and we can create camera Y. So here the axis should be Y. All right. So next let's create camera X and camera Y for the joystick. So I'll just duplicate this camera Y element. Let me rename it to camera X. And the type of this one should be joystick axis. And for the axis, we'll select the fourth axis. So the fourth axis is the horizontal axis of the right analog stick. All right. So now in case of joystick, we also need to tweak a few settings over here. So let's look at how the left analog stick is set up for the horizontal input. So here you can see that the sensitivity of the input is 1. And for the value of the dead, they're using 0.19. So we can also do the same for the right analog stick for our camera X input. So I'll change the sensitivity to 1. 0.1 will be a perfect value for mouse, but it'll be really low for analog sticks. So let's change this to 1. And we'll also change the value of dead to 0.19. So this will be the dead zone. If the value is below it, then it will be mapped to 0. All right. So we have set up the camera X input for the joystick. So next let's duplicate this and create the camera Y input. All right. So the y-axis of the right analog stick is the fifth axis. So let's change the axis to fifth axis. All right. So that's all we have to do. So now we have a new input which can be controlled by both the mouse and the joystick. So let's use this input for rotating our camera. So in the camera controller script, instead of using mouse X and mouse Y, we'll use camera X and camera Y. All right. So now we should also be able to rotate the camera using the right analog stick. So let's go ahead and test that. All right. So now I'm also able to rotate the camera by using the right analog stick. Okay. So now we can also control our third person controller using a joystick. So now we have a pretty decent third person controller. And the best thing is we built this from scratch without using any assets. So congrats on reaching this far. If you want to build on top of this and create a more advanced controller that can perform parkour actions like this, then check out our Unity third person parkour system course on Udemy. I'll put a link in the description if you want to get it for a discounted price. So I hope you found this video helpful. Thanks a lot for watching, and I'll see you in the next video.